Hey guys, this is going to be a relatively brief little presentation here on the conclusion and consensus for Castle's Unit 5, Activity 4. This is the one where we had 3 circuits, all of them containing a round and a long bulb in series, and then we were adding different bulbs, a long bulb and a round bulb, and then a shorting wire in parallel to that first long bulb. Okay, so what we saw with this was that in circuit 1, where we added a long bulb in parallel, we did see a very small change in brightness of the long bulb, so we do know that that flow rate decreased a little bit. But definitely we did also see an increase in flow through wire A being the one that leads from the positive side of the battery into the round bulb. So there was an increase in flow through that round bulb, through that trunk wire, if you will. Okay, so A is a trunk wire because it's going to split into wires B and C. There was an increase in the flow rate there, but not enough to light the round bulb. Okay, in circuit number 2, we added a round bulb in parallel with the long bulb. And what we saw happen there was the flow rate through wire A, that trunk wire, increased a lot more, and we did see that round bulb light. We also saw that the flow rate through wire B decreased, and the long bulb got a little bit dimmer. We weren't able to see that through the compass deflection because the compass deflection was already so small, but we did see that long bulb get dimmer, so we do know that that flow rate decreased. Now, the reason that the flow rate increased so much more with the round bulb in circuit 2 compared to the long bulb in circuit 1 is because that round bulb has a lot less resistance than the long bulb, and so it lets more charge go through it. Now, in circuit number 3, we had a similar thing happen. We saw even more charge flow through wire A, that trunk wire, but the first branch wire, wire B, had no flow through it, or at least very, very little flow, not enough flow to make that long bulb light. Whereas wire C, that shorting wire, which has very, very little resistance, saw a lot of charge flow. We were able to see that. The same amount of charge flow theoretically as the trunk wire, wire A, because all of the charge that goes out of wire A has to either go through wire B or wire C. We can't lose any of that charge. Since we didn't see very much charge going through wire B in circuit number 3, that means all of the charge that's moving out of wire A must be moving through wire C, and that's why the long bulb doesn't light. It's because that charge always takes the path of least resistance. Okay, what I'm going to do now is I just want to color code each of these circuits. So these are circuits numbers 1, 2, and 3 on the sheet from left to right. We already did color code them a little bit together earlier in the previous video. But what we see is that, as always, the top of the battery, the positive side of the battery, its job is to keep that top wire, wire A, at a red pressure. It sends an excess of charge into it, and that round bulb blocks some of that charge from moving through. It resists the flow of charge through it, and so it does get a red pressure. Similarly, the bottom of the battery, the negative side of the battery, has the job of sucking charge out until it brings that wire that it's touching to a blue pressure. And that long bulb, again, those bulbs resist the flow of charge so that they prevent some of the charge from above it from moving in. Okay, so the charge that's up here, it doesn't quite move in there, and so that is why we only draw the pressure up to the bulb. Now you notice something interesting then happens with circuit number 3. and that is that since there is no bulb on wire C, because it's a shorting wire, that blue pressure continues through that whole rest of the circuit there. And so you see there is no pressure difference across that long bulb, which is why it does not light. In circuit number 1, we saw that the round bulb didn't light. So I'm going to draw it as a red pressure. It has to be slightly less than red, like somewhere around red-orange, but I don't really have access to that color. It does have to be slightly less than red because there is some charge flow, we do know that, but it's not enough to make that round bulb light, so it's okay if we don't really see a very measurable pressure difference there. Okay, whereas on the next one, we saw that both of these round bulbs had the same brightness. And since both of those round bulbs had the same brightness, that must mean that they have the same pressure difference across them. And red to yellow and yellow to blue are both 2 steps. So that wire we're going to color yellow because, again, those round bulbs had the same brightness. Okay, I tend to get questions a lot about how we know what color to color it, and a lot of it kind of is that there's that 2-step process that I just kind of showed you. Step 1 is to color the red and the blue wires, because we know that the battery is going to have that jump from blue to red on all the wires that it's touching, so that's the first step. And then the next step then is to kind of guess or infer the other pressures from the brightness of the bulbs that we're seeing. Since we know that in circuit 1, this bulb right here does not light, we know that there must not be a pressure difference from A to B. And since in circuit 2, these two have the same brightness, we know that this wire right here must have the pressure that's directly in the middle of the red and the blue. So that would be yellow. And again, it's not a perfect science, guys. It's not. This is a very qualitative thing. It's not guessing. It's an educated guessing. But it's also, there's no numbers attached to it, and they're just colors. It's very, very qualitative. It's not quantitative at all, so we don't have to focus on it too awful much, just as long as we're kind of showing the right thing. Okay, moving on to our consensus. What we saw through both that color coding activity that we just did and the observations that we made, we saw that adding parallel branches to any part of a series circuit reduces the overall resistance of the circuit. So each item, each bulb, each resistor in the circuit has a resistance, but they also all together have a combined overall resistance for the circuit, or sometimes you'll hear that called the equivalent resistance. And whenever you add a bulb in parallel, it's always, always, always going to reduce the overall resistance of the circuit. That's why whenever we added something in parallel, no matter what we added in parallel, we did see the current or the flow rate through the trunk wire, or wire A in this case, we saw that increase because the decrease in overall resistance increases the flow rate through the trunk wires, which are connected to the battery. So it's increasing the flow rate through the battery. Something else that we saw is that the pressure in the wires mostly depends on the branch that has the lower resistance. In circuit number 2, right here, in circuit number 2, the long bulb, we didn't really try to guess the pressure in that wire based on the long bulb. We saw that those two round bulbs were the same brightness, which means that we could have just taken the long bulb out and put the long bulb on the right side, and that would have been the same circuit. I'll try to make that a little clear. If we just took this long bulb and this round bulb and we switched them, the circuit would be the same. That wire there would still be yellow. And that's just because that round bulb essentially has all of the control there. I guess one way you can look at it is, since the round bulb has the lower resistance, it's letting the charge move through from wire C and through that round bulb better than the charge is moving from wire B into and across the long bulb. So the one that has lower resistance, because it lets more charge through, that's really the one that has the control. And we see that in circuit number 3 with the shorting wire as well. Since that blue wire has very little resistance and it just lets all that charge move through it, it really has the control of how much pressure is in each wire. Okay, the last point that I want you to make on that is that when the branches have different resistances, most of the charge does flow through the path of least resistance. Even though, so I'll go back a slide again, even though having a little technical difficulties here, even though we do see that there is the same pressure difference across the long and the round bulb in wire or in circuit 2, there is more flow through the round bulb. We can see that both by looking at the deflection of our compass, as well as the brightness of the bulbs, which again isn't really a perfect science when we're talking about two different bulbs, but we do know that that long bulb has more resistance and we do see less of that compass deflection, so it must have less charge moving through it. Just like in circuit number 3, wire C, that shorting wire, has very little resistance, and we do see a lot of charge flow through that, but essentially no charge flow through the long bulb. And that is going to end up being proportional to the resistances of the bulbs. That's something that we will be looking at the numbers about that more later in the next week or two, hopefully. All right, guys, make sure you get these notes taken down, and then go ahead and submit the Activity 4 worksheet to Canvas. Have a good day, and see you later.